All right, let's talk about visual hierarchy. When you look at a map, your visual hierarchy tells you what's the most important thing there. So whatever you are trying to convey, whatever kind of information you're trying to get out there, your visual hierarchy, the way you design your map, is going to help you get that information out the way you want it to get there. So visual hierarchy. Okay, I thought my slides were not working. Let's look at this map of Maine here. If you look at this, visually what we see on here, we see Maine population, we see a little map of Maine, see a north arrow, big north arrow, and then we see this legend down here, which is ridiculous. We've got so many different categories, way too many. You should have about 7 at the max for just a general purpose map for the public. 7 categories is about all the mind can handle. So the most important thing on here, this visual hierarchy tells me, is this population legend. Well, that's kind of ridiculous because you should be looking here to see where these types of population are, where this 10,540 to 13,887, where are those people? We can't even tell because the map is so small. This is better. It's not perfect. We got some problems with the legend. We got the legend categories butted up against the legend boundary. We've got a really weird scale bar here that goes from 0 to 960,000 feet. Doesn't make sense because we don't usually measure across states in feet. But we can tell where these population centers are based on the coloration and our legend. Legend makes more sense. Not perfect again, because you would want to have population in 1999, not pop 1999. The north arrow's okay, it's not great, but it's not screaming like it is here. It would be better if your map, this main map, was larger. It took up more space here. You can work with your title, move it around, and give yourself a better scale bar. But visually, this one is much better than this one. Okay, so let's look at these maps here. What are we trying to convey? We are looking at vegetation classes in the Democratic Republic of Congo. Now, does your map go along with what? Does your map itself, your maps, does it go along with your title? Because here's Congo here. There's nothing on this map that tells us this is Congo. This is up here higher. Why is this here? What's going on here? It doesn't say in our title here. It doesn't say a word about the national parks. But here we've got the national parks. So we've got some problems. We've got a scale bar just floating around out here. We've got a north arrow out here when we don't need it because we've got the granicule. We've got some insets here and here. We still don't know why that's there. This one's better. Got a better location, better visually more pleasing design here. You've got your inset over here. I'm not too crazy about that, but it works better than it does over here. Your legend's a little bit big, and it kind of stands up in the foreground. Again, we're going with visual hierarchy. What does the map visually tell you is the most important? And so here it tells me vegetation classes are really important. We still don't know why this is here. And let's look at this. Now, it's starting to make a little more sense. This is the last map that we saw. Now, if the actual focus of the map is supposed to be those national parks, then this is what the title should be, not Congo and all this other stuff. So now it makes sense. We've got our national parks, largest thing on there. We've got a couple of insets and appropriate locations to tell us where what we're dealing with. We've got this labeled as enlarged area, like over here. It's like, what? Okay, why? And we can actually see these areas much better. It works so much better for the eye. I know when I look at this map here what I'm supposed to be looking for. I'm supposed to be looking in at national parks. So your visual hierarchy will tell you what your most important things are. The ground. what's on the ground. So we see the two faces here. What do you see here? Two faces or a vase? So you want the ground to work with you. You don't want to work against you. If you want to show off a vase, you want to make sure your background is not in the shape of two faces. Got it? So you don't want to have a distracted background. Generalizations, these are the things that when you're at certain scales, a certain size of the features, you might want to generalize. Let me show you what we're talking about here. So right here, I'm going to go ahead and jump down here. What a good example of generalization and simplification. Let's say this is a river, and rivers meander all over the place, and they wiggle and wind and go here and there. At certain scales, you don't want to have every single wiggle and wind and meander in there. You will want to smooth it out so you can simplify things. You can generalize vegetation. Here's an example of vegetation, road classes, that sort of thing. You can generalize them. You can be very specific and say you've got red oaks versus oaks, white oaks, ash trees, and explain each one of those types of trees. Or you can just say trees, or you can say vegetation. So you need to determine, based on your audience and based on the purpose of the map, how general and how specific you want to be. You can do some exaggeration if you need to. And also, think about what sort of symbols are appropriate. What's really neat about the Esri product, ArcMap, is that you can choose, like I showed you the other day in the Wells exercise, you can go in and choose different types of discipline, like environmental or civic or crime, and there are specific symbols related to that field. So that's kind of a nice thing. Consider placement, where you want to place your labels when you get to doing labels. More on text placements. You want to work with these so that your labels are not distractive. They're not covering other things up. And choose your elements. Do some research, figure out what you want, see what's out there in some other maps. And GIS tools are not always the best cartography tools. In fact, the person that teaches, often the person that will teach a cartography course, and I think even the person at ACC doesn't always use ArcMap for cartography. So, choose your map type. There's hundreds of different types of maps. There's hundreds of different types of projections. Not all GISs allow all types of maps. Some types of GIS work better with certain types of maps, like the land use classification, or what we just saw with the vegetation type. There are certain types of GIS that work better with those. Let's see. Okay, so why would you choose the wrong type? Well, GIS people are not necessarily cartographers, so it's a good idea if you are trying to get a really high quality map. Let's say you're working out in the field, and you need to have a really high quality, very professional map, and you are a GIS analyst, and you've been studying GIS, not so much on cartography. It's a good idea to get in touch with somebody who does maps for a living. If you can reach a cartographer, or even get on some of these work groups online and have discussions with people, they can help you out in creating a nice map. Different types of ways to show point data. You have dots, you can have special symbols. There's actually picture symbols that are out there. And again, you'll see on in the ArcMap all the different ways you can symbolize things. You can also have graduated symbols where if you have a city of 100,000, you can have a bigger dot on the map than you have for a city with 5,000 people in it. There's a lot of different ways to show data. Okay, now let's talk specifically about reference maps. Excuse me, I have something in my eye. So here's a map of the major roads of New York City. You can see here that different cities have different size fonts. We can see roads, we can see city boundaries, we can see water bodies, information like national parks and recreation areas, The little ferry, a little line data right here for the ferry that goes back and forth between Trumbull and looks like Port Jefferson. I've never been to New York, so I'm not so up on the geography there. So that was your reference map. Whoops. Let's go back to full screen here. There we go. So that was your reference map. There's some other ways to show area data besides on the reference map with those different colors that you saw. There's the choropleth map. I always mispronounce that and call it choro. It's called choropleth, not chloropleth. I always want to say chloro, but I guess I'm thinking Clorox or whatever. We'll look at each one of these, the area qualitative, the step surface, and the cartogram, and then we'll look at the reference map again. Okay, so let's look at that type of map, that choropleth map that I can't pronounce. A choropleth map is a map that's basically color-coded. You see them all the time. It shows the different categories or the different data in different colors. So in this case, the states with the most, whatever this is green, are green. So we see a color-coded map, basically. When you saw the population map a while ago, that was a choropleth map, where it showed the different degrees of population by the different colors that you saw. Here's an area qualitative map. It doesn't really have a scale going from dark colors to light colors. This is a soils type map. Shows the different soils type, and it's color coded, not so much like the choropleth map, which goes based on the categories of scale, categories by number. This one goes by soil type. Let me show you another one, the land use, land cover. I've mentioned land use, land cover a couple of times in this. Each different class of land use or land cover has its own color in this case. So it is also color coded, but again, it's not based on a scale or a range of numbers. All right, here's another area qualitative. This one is based on low to high, but it doesn't have a set of numbers. So low fire danger is green, water's blue. The highest is extreme here is the red. If you've seen a drought map, that's another area qualitative type map. The stepped surface is a 3D type map where we're showing, here's Maine again, and we show by category, usually a numeric value is tied in with this, and each county here is raised to a certain level based on that number. We'll do some of this stuff when we get into the 3D mapping. This is a lot of fun to work with. Now, another step surface map. There you go, step surface. It's essentially a 3D map where you have extracted or extruded, is actually the word, certain map features to be higher on the Z scale, which is your third dimension in your 3-dimension map. We'll get into these more again when we get into 3D maps. Cartograms are kind of neat, and they're becoming more popular. You used to not see these very often. It takes numeric information, and it shows it. Let's just look at an example here. We're looking at populations here, and it sort of it makes the country here the size based on the size of the population, and it sort of maintains the shape of the nation. India looks kind of crazy here. It looks like some sort of water pump to me, but China kind of has the shape correct, and Japan and the United States and Brazil, those are pretty good. Some of the other ones, Russia, not so much. But a cartogram, let's go back up here. Here it is. It says it illustrates the relative size of the populations of the countries of the world by scaling the area in proportion to the population, but it kind of maintains the shape. It doesn't always have to be based on population. but it generally will be a population of beer drinkers. I've seen cartograms based on population of beer drinkers versus population of wine drinkers, those sort of things. So it will be based on some sort of numeric value tied in with that geographic location. Here's another one, cartogram of the United States. Here's a cartogram of Elvis concerts. So remember, I said it doesn't always have to be based on specific general population. This is population of the Elvis concerts from 1970 to 1977. Notice here it says Nevada, Las Vegas. It was too big to put on the map. So apparently Elvis liked Nevada, California, Florida, Georgia, hated Mississippi, which is interesting. That's where he was from. He didn't do any concerts in Mississippi or Arkansas. So anyway, cartogram. Fun stuff to know. Here's an old map, 2004 election, looking at which states voted for whom. This is the Bush and Kerry election. So you see the Kerry is in blue. That was about the time we started this dividing ourselves into red and blue. But you can see the populations of the states, and the states are color coded by who they voted for. So we can also show volume on these different types of maps. We don't usually use this gridded fishnet anymore. We've got a lot more sophisticated ways of showing, and this is a population map of Arkansas in 3D based using this fishnet. Look, we don't usually have to do that anymore. We can show it in a more realistic fashion or a different fashion. We don't always have to have the fishnet, but it's still in use. Realistic perspective. This is what Google Earth does, and if you go into Google Earth and you click on 3D buildings, you'll see very realistic 3D buildings of downtown Austin. It's really pretty neat. And Hillshade. These are things that you will be doing when we get into 3D mapping. So we'll also do one of these as well, without the buildings. I'm not good at drawing the buildings. All right, you have different ways to demonstrate time. Different ways to demonstrate time using multiple views. We also have animation to show how things change over time. And then we're going to wrap things up with choosing types of maps. You want to pick a map for your map type for the type of data that you're using. You also want to consider if you have a lot of points, lines, areas, volumes, what are you looking at in your dimension? What type of scale of measurement are you looking at? Are we looking at, this is covered in the text, but are we looking at nominal data, ordinal data, interval, or ratio data? Ratio data means you have an absolute zero. So if you're measuring in dollars, dollars spent on air conditioning in the state of Texas. So that would be a ratio because well, I guess some people go in the negative, but you've got $0, or you can spend $500, $1,500, however much dollars. That's considered ratio. Nominal data is going to be like names. Place names, that sort of thing. Ordinal, that's rank order, like we saw with the map of the fire. Extreme, warning, moderate, not a threat at all. That would be your ordinal. And interval is like ratio, only you can go into the negative. That would be something like temperature or sea level and altitude. Also consider what your GIS can do. If you're making a map using Google Earth, it's kind of limited. You may have to find a way to supplement your GIS software. You may end up needing to use something like Adobe Illustrator because our GIS is sometimes limited. But that's where I'm going to drop off for today. Again, we will get into some more of the details when we get into 3D mapping and different types of map. But I wanted you to get a good idea of what goes into the artistic part of designing a map. A few other things before I leave you. consider balance in the map. Let's go back here. You want your map to be balanced, and you don't want to have, like, this is a nice little legend right here. It's got nice placement. If you had the legend over here, there would be too much of a figure, too much stuff over here, and then we'd have all this white space. So you want to have a nice balance. You want to place things, again, consider the visual hierarchy. Don't put your legend up here next to your title. Don't put your name and the source data right across the middle of the map. Consider those things. Those are pretty obvious, but I want you to consider those things as you do your maps. So, Chapter 7, Exercise 7.2. If you have any questions, don't hesitate to get in touch with me. Hope you have a great day. And again, give me a call. Don't hesitate to give me a call or send me an email if you have any questions.